Good afternoon. Which street do you prefer? This one or this one? All right. All right. Okay. I think first of all, this is my name, right? You haven't met me before, so I am the unit coordinator for this unit. For Maths 67121, I am the unit coordinator, right? You already had lectures with Dr. Selina. Everybody settle down? Okay? So, for this unit, constructed textiles for fashion, there are 3 lecturers. You already met Selina Jones, Dr. Selina Jones, right? I am actually delivering the knitting or knitted structures related lectures, and after my 3 lectures, there will be another 4 lectures with Dr. Shogun Chen on the woven structures, right? So before I start, probably I should tell you that I think it's the same the administrator from the teaching and learning who was here earlier, actually scanning your QR codes. She's coming back again at 2:40. Usually we are required to finish the lecture 10 minutes before the hour. That means usually at 2:50, right? But that lady is actually coming at 2:40. I think there's some information she wants to give to you, right? So I will be finishing today's lecture, only today's lecture, at 2:40. But stay seated afterwards because the teaching and learning administrator is coming to give you some information. All right? And the other thing I need to tell you is that, okay, from this week, knitting lectures, and then I think on the 6th week you have, there's no lectures in 1 week, reading week, right? And thereafter you have another 5 lectures. 4 lectures with Dr. Shogun Chen, and the very last lecture on the 12th teaching week. The first hour is taken by Dr. Shogun Chen, and the next hour is taken by me. All right? So next week, say from next week, you will have seminars related to knitting, and thereafter you will have, I think, related to weaving as well, right? And either in those weaving or knitting seminars or in the lectures, if you have any problems, right, and not only them, even if you have any issues related to the reports that you are supposed to write, anything related to the, any information in the blackboard, I would prefer it very much if you can first contact me, right? So let me know. Either you can come to my office, A35B1 in the Sackville Street building, or you can email me, right? So I'll try my best to sort it out. Or if there's something that is difficult, I will direct you to the correct person, right? So first let me know what's, if there's any issues, let me know. Sometimes things that happen is maybe when I'm talking, not everybody is hearing. Or maybe I may be talking too fast. Am I? All right. And sometimes what happens is during seminars, now for seminars there's I think 8 instances of seminars happening, 8 different classes. Some of the teaching assistants that are teaching in those classes, they may be talking too softly, or they may be, their talk may not be clear, it may be difficult for you to understand, right? And sometimes what happens is when that happens, students start leaving the class. They send me emails asking whether they can go to a different class, right? So if that happens, if you find that there's, if the TA is not performing well, or if you can tell me what the problem is, let me know. I will talk with the TA, try to sort it out, or otherwise try to get a different TA or something like that, okay? So if there's any problems, first let me know. Probably I should again say something that from the, well, I mean experience from the last year. Now you are supposed to actually submit a, well, it is a coursework report for Dr. Selina Jones' work, right? For the workshops you had, right? Now don't wait until the last moment to submit them. At the last moment when you try to submit, there's problems. There was some students, or at least one student I remember, she had actually submitted to the wrong place, and she didn't notice it until much later, by which time it was too late, right? And then there's probably you got the information as well that if the coursework submission is late by a certain number of dates, you don't get any marks. So because of that, try to submit them early, otherwise at least on time, okay? And if there are any problems, let me know. I'll see whether I can sort the problem out. And when you submit the files, right after submission, check to see whether it is there in the Blackboard. It is, you are submitting the documents to the Blackboard, right? So check whether they are in the Blackboard, right? And also Selina asked me to inform you that she's already told you, but she still asked me to let you know that the report that you are writing, she's not marking any knitting related information. She's only marking the whatever information she taught you, right? Okay. Probably we should start going through the lectures. Now, you know that the amount of time that's available for us, available for me to teach and for you to learn, the knitting subject is only 3 days, right? 3 weeks means 1 hour and 50 minutes, there's 3 of them, right? And Now, you know that because you are new to this area, I think you are mainly management students, right? Am I right? Okay. So because of that, this subject may be new for you. Are there any people here who have studied textiles before? One, right? Yeah, last year there was one as well. Yeah, right. So this area is new. Because the area is new, I'm supposed to actually go through this slowly, right? So by going through this slowly, you will, if I try to give you all the information or give you notes and everything as well, we won't be able to cover much ground, right? So because of that, the presentations are very much graphical. There are information there. They are very much graphical. Now, there are keywords in them. You are supposed to say, as say MPhil students, you are supposed to read on the background to these lectures. The recommended texts for this are actually in the handbook. You know where the handbook is, right? In order to help you, at the same time, in order to help you, what I will do is, soon after my 3 lectures, I will email you some extracts I've taken out of textbooks, right? Those, now if you don't read, those will at least help you to get prepared for your exam. You know, for your exam, there's 2 knitting related questions, 2 weaving related questions. So section A has 2 knitting related questions. Section B has 2 weaving related questions. You are supposed to do 1 from each section. In order to get ready for the knitting questions, I will email you more information on the things you learn here. Also during the seminars, the TAs, the teaching assistants will go through past papers, right? They will go through these lectures first, and then thereafter they will go through some past paper questions and show you some outline answers, how you can answer those questions. All right? Okay. So if we go to the first slide. Okay, as the topic says, so it is constructed textiles for fashion. Now, when I want to give you information about textile material, I need to, I think, start at the very basics. Mainly, the information that you all need is ability to know about the basics of structures, ability to converse about the knitted structures, maybe recognize some of the structures, and also know about how to represent different structures, how we can actually show different structures through some easy graphical methods. So that if you want to actually let somebody know about some information that you want to communicate, there's an easy method by which you can show them. Something like shorthand like, right? And the other thing is some basic information about garment manufacturing. We'll try to do all of this depending on the time available. You need to try to do all of this within something like 3.5 days. Right? Now, in looking at fabrics, So the easiest way is to, if you look at the garments that you are wearing, if anybody is wearing, say, so some will be wearing woven garments. So the shirt I am wearing, it's a woven fabric, right? Some of you may be wearing T-shirts, pullovers, cardigans, where the fabric is actually a knitted fabric, right? So it is those two types of fabrics that are represented here. Okay, you might think that, okay, the woven structures you are wearing is no way like this, and knitted structures you are wearing are no way like this, right? Okay, think of this as the fabric structures, they are actually expanded in order for you to see the yarn parts, how the yarn is interconnected, right? And here, the knitted structures in a normal knitted garment, how the loops are interconnected in order to make a knitted fabric structure. Okay? So you see here as nice loops, but in reality in the fabric, it's all squashed, it's bent and squashed, right? And you don't see much, say, openness in the fabric. In the woven fabrics, the yarn will be very dense. You won't see much light through it. Okay? But when we are learning, because we need to understand about the structure, it is important we see the parts of the yarn. All right? So that's why we have drawn them like this. So in either case, what we have are yarn being used to manufacture fabrics, right? And the yarn, or a certain collection of yarn, is converted to fabrics by binding them in certain different ways. There's a certain different type of binding here, which we call interlacing. There's horizontal set of yarns, and there's vertical set of yarns. So there's two sets of yarns interlaced in order to get the woven structure. This is one of the possibilities, one of the possible structures. There's many other, very large number of different structures you can create, which you will learn with Dr. Shogun Chen. Okay? In here, knitted structures, again this is one of the many possibilities. There are different, very high number of possible ways by which we can interconnect those loops in order to produce a knitted fabric. We call that interlooping, right? But this type of fabric can be created with only one yarn. That means one yarn package. Here, you need more than one yarn package. So all of these vertical ones, they need separate yarn ends, right? But here, with a single package of yarn, you can create a knitted structure. Once you create them, once you take the fabric out of the knitting machine, it will become like a knitted fabric that you may be wearing, right? The fabric will be relatively dense. The loops squash together, okay? But still, the yarn parts are like this, a curved yarn path. They have a curved yarn path. So that's the main difference between woven structures and knitted structures. It's not our purpose to actually learn, during my lectures, learn deeply about woven structures. But we need to see the basic differences between them. Basic differences between the woven structures, basic differences between that and knitted structures. Okay? So you can straight see here the yarn. Yarn is actually going over under path. We call that undulations. Right? So if you look at the yarn parts, they are more or less straight yarn. When you try to stretch the fabric, we are trying to stretch a set of yarns in that direction. Okay? It's like, or we will say that that yarn is a straight, something straight like this. So when you try to stretch the fabric, it's like you are trying to stretch a straight yarn. It's difficult, isn't it? Because we are trying to pull a yarn which probably is not stretchable. And you are not trying to pull one yarn, you are trying to pull a set of yarns. So it is very strong. But if you look at this fabric, it is made out of loops. That means, okay, something like this. Loops. Many loops interconnected together, right? Now, if you take a single loop, try to pull it, what are you doing? You are unbending the yarn. Unbending is easier, right? Unbending is easier than trying to pull a yarn. So generally, because of the loop structure that we have in the knitted fabrics, they are more stretchable. This is not that stretchable. Right? If you consider the dense fabric, relatively this is much more open than that structure. Like that, there are different, say, features on these fabrics. So that is again something that you are supposed to identify, learn about. Right? So if we go to the next slide, it is much more denser. It's a woven fabric, much more denser. So as we go along, at the same time as we are learning about different fabric structures, we are learning about terminology as well. So we first saw the difference between woven structures and knitted structures. And we looked at, okay, the yarn parts in them, how the yarn parts contribute to the features or characteristics or properties of the fabrics. And then as we go along, we learn more about them. Say if you are in a, say, in a buying office or in some, say, company where you need to talk about the fabrics. Say you have a certain sample of fabric, a knitted fabric. Now you need to talk about that, the fabric structure in that knitted fabric with the knitter, the person who knitted it on the knitting machine. For you to do that, you need to be able to, or you need to know the terminology related to that fabric structure. You need to be able to refer to different parts of the fabric or different features of the loops or different features of the sets of loops, their direction. Right? So because of that, it is important that we learn about the terminology associated with knitted fabrics. Right? Now, for woven fabrics, you can see the vertical set of yarns. They are called warp. It's not always vertical. See, if you hold the fabric like this, then those yarns are vertical, right? So those yarns, they are called warp yarn. And the horizontal set of yarn, they are called the weft yarn. Right? So the fabric is made by binding the weft yarn and the warp yarn through interlacing. If you go to the next slide, we are now looking at knitted fabrics. Knitted fabrics are made out of loops, but you see here there's two types of knitted fabrics. These are two main variations, right? This type of knitted fabric, where the loops are continuing in the horizontal direction, or if you use the same terminology as the earlier slide, in the weft direction. So the loops are continuing in the weft direction. Those fabrics are called weft knitted structures. The structure is called weft knitted structure. Now here again these fabrics, they consist of loops made out of yarn, but the way they are bound together is different. The loop is continuing in the horizontal or weft direction. Here the general direction in which the loops are continuing in the continuous yarn is in the vertical direction or warp direction. It is true that it is actually going side to side, but still it is continuing in the warp direction. So those fabric structures, those knitted fabric structures, are called warp knitted structures. They have different properties, right? Say if you try to stretch them, what happens, how they bend, how they are manufactured, those things are different, right? So again, we should actually know about the differences between these. So how a woven structure differs from a weft knitted structure, and how those two differs from a warp knitted structure. And depending on the yarn parts in the structure, how we achieve different properties in the fabric or different features in the fabric. It's not, it's not about, I'm not talking about any color designs or anything like that. What I mean is, say, physical properties or characteristics, how they behave. Okay? So it is important that we know. So in this diagram, because sets of horizontal or weft direction loops are connected, we have those horizontal set of lines. Here, sets of vertical direction loops are connected. We have these vertical lines to represent them, right? We usually, certain structures, these structures, it is possible for us to actually knit them by hand. But in the industry, we have machines to knit them. There are manual machines which will make the knitting of these fabrics much faster, or there are electronically controlled, computer operated knitting machines as well to produce both these fabric structures, which is much, much faster. Generally, manufacturing warp knitted fabrics, the machines that do that, they work very, very fast, right? Weft knitted manufacturing, not that fast, but still certain types of machine can produce these structures at a very high rate. Okay? But you are supposed to actually see the differences in these fabric structures, right? So if you look at the applications of them, so these are differences as well, right? Wave knitted structures are mainly used for garments, apparel products. Say the pullovers you are wearing, or t-shirts you are wearing, cardigans, and normally undergarment, say leg wear, all these, they are knitted fabrics. They are generally wave knitted fabrics, right? So as you can see here, some examples: socks, the socks we are wearing, any leg wear, different innerwear like vests, right? Leisure wear, the sports garments, swimsuits. Well, some of the swimsuits are actually made with warp knitted fabrics. Then jersey wear, tops like cardigans, pullovers, right? And some knitted skirts. They are all actually created using wave knitted fabrics. So these are some pictures where you can see different designs. So the machines that are used to create these, they are able to actually knit different colors together. And those machines, today those machines are actually computer operated. And you actually operate, or you design different fabric structures through CAD softwares. And because of that, it's possible for you to actually create different color designs, different structural designs. All that can be created. You can create fabric structures with all these changes, different features. Okay? And these are some other possibilities. Sportswear. So something you should know is that today, when these days when we actually manufacture these garments, it's not that it is any fabric is taken and then you cut and sew a garment with that. The fabric structures are actually designed for a particular purpose. For if it is for leisure wear, it's one type of fabric. If it is sports garments, it's another type. And sometimes these sports garments are actually fully knitted in the knitting machine. There's no sewing operations. There's no sewing of fabric panels together. Completely knitted, so there's no seams. So usually we have side seams, isn't it? When you have a front part of the garment, front panel, and the back panel, when you sew them together, there's a seam at the edge, right? So there are these high-end garments, they are actually knitted seamless. And that is completely done in automated knitting machines. They are whole garment knitting machines. They are called whole garment knitting machines. Right? And those structures, they are again engineered as well. Wherever the sportsman wants to actually make sure the sweat is actually moved out of the body as fast as possible, the structures are engineered for that. And that involves different fabric structures, different knitted fabric structures. Right? So a garment could have different structures depending on the purpose for which it is made. Right? Are there any questions up to this point? So remember, you all can ask questions because you are, say, any question is okay as long as it is meaningful, right? What I mean is this. Don't think that you are asking a wrong question or something like that if you don't know about it really, because you are from the management side. If I ask any questions about management subjects, I would probably ask well, wrong questions as well, right? So if you want to know, if there are some information which you didn't understand from my lecture, let me know. I'll try to answer them. Without, as far as possible, without slowing down the lecture, I'll try to talk about it again. Okay? If there's any questions, let me know. All right? Okay. So these garments, they show you, okay, different possibilities. Again, it tells you why we need to know about different fabric structures. Different fabric structures have different performances. They can be used for certain purposes. Now, a garment that is used for one sport may not be suitable for another one. Right? It will depend upon the body action and how much stretch of the arm movements. Right? So sweat movement through the garment. So all of that would need to be considered in selecting the fabric structures. And again, depending on the purpose, say if it is sports garments, you need to engineer the structure, or you may engineer the structure. Or if it is normal leisure wear, again, it will be different. It will be engineered for the purpose for which it is used. All right? So these are some pictures. Baby wear, say flannel fabrics. So that means for controlling the thermal environment. So knitted fabrics have those features. Because knitted fabrics are relatively more open, porous structures. When the fabrics are near the body, they are able to have the warm air near the body in the fabric. So that means that you are maintaining a warm layer next to the skin. Right? So if you are wearing a knitted, say something like a vest, a body hugging vest, because the structure is more open, it has loops. So inside the loops there are more open areas. When it is next to the skin, those loops are able to hold the surface warm air in them. Right? So that means even if the heat is radiating away from the body, still the fabric structure gives a resistance for the air movement. It holds a certain warm layer next to the skin, which makes up warm. Woven structures, when you wear, say in hot weathers, there's an air gap between the body and the garment. Right? So by that, it's able to actually have a cooler environment around the body. So that way, the fabric structure actually can engineer or can actually design the kind of microenvironment around the body. And we do that by designing it properly, by deciding what type of structures are used. Okay? So in order to do that, we need to know about the fabric structures, different fabric structures. Because we don't have much time to learn about all the fabric structures, we will have to actually limit the learning to a certain basic number of fabric structures. And when we try to learn about those fabric structures, we need to know about the basic building blocks of the fabric structure. You have yarn. Yarn is a building block. But again, those yarns are used to create loops. And loops are interconnected, interlooped in a certain way. And depending on that, depending on how they are actually interconnected, we need to know how to refer to, okay, the front of the fabric, back of the fabric. How do we define that? Or the loops at the top of the fabric structure and the bottom of the fabric structure. And any loop in the middle of the fabric structure. How do we refer to them? Because you need the ability to talk about them with somebody else. Maybe a knitter, maybe somebody from another company, right? That's why we are going through these lectures. All right? Okay. Earlier we talked about applications from weft knitted fabrics, for weft knitted fabrics. Now we are looking at applications for warp knitted fabrics. Now the way the warp knitted fabrics are made, the machine that manufactures warp knitted fabrics, it uses strong yarn. I told you, if you can remember, that you need many ends of yarn or many packages of yarn to construct a warp knitted fabric. At the same time, the machine that is used to build them, right, it needs to actually function under a certain tension, yarn tension. Because it is a higher yarn tension, in order to tolerate that higher yarn tension, the yarn need to be strong. They need to be as strong as weaving yarn. And because of that, warp knitted structures are quite strong compared to weft knitted structures, compared to, say, maybe the cardigans or pullovers that you are using, that you are wearing. Warp knitted fabric structures are much more strong. Okay? And that means the yarn that are used, they are strong yarn, they are wear resistant yarn. And they may have different other features. Right? So that makes these warp knitted fabrics suitable for household products like cleaning fabrics, things like that. Or then other technical fabrics like, okay, car seat covers, seat covers you use in, say, buses, planes, because people keep on sitting, getting up, sitting, getting up. So each time the fabric stretches, contracts, stretches, contracts, it goes through these cycles continuously. Right? So the fabric needs to be able to withstand them. Otherwise, their change in time would be very short. So very often, the bus owners would have to actually change them. So that's why stronger fabric, warp knitted fabrics are used, because warp knitted fabrics can stretch more, generally more than woven fabrics. At the same time, they will have good strength. Compared to weft knitted fabrics, good strength. Because we need both those features. We need them to be stretchable, and when the person gets up, it needs to go back to the original level, right? And they need to be wear resistant as well. So we use warp knitted fabrics. So what are the other features? Warp knitted structures are used for high load bearing applications, because the stronger yarn that are used make them suitable for that. Okay? Any questions? Anything you didn't understand? High load bearing means, okay, even say car seat cover, right? When a person sits on it, so the person's weight has to be borne by the fabric. That means when you sit on the fabric stretches. If the yarn are weak, yarn would break, and then there would be a tear in the fabric. The feature of the knitted fabric is, if it tears at one place, it continues, right? But warp knitted fabrics, because they are using strong yarn, even when it stretches, it won't break. They are designed to perform like that, right? So high load bearing applications. There may be many other instances, like compression garments. They may be used for compression garments, or they may be used for, say, swimwear, where when you wear them, the garment is supposed to actually form the body to a certain either fluid dynamic shape or aerodynamic shape, something like that, right? So at that level, the fabric is tensioned, very much tensioned. But the fabric needs to be able to withstand those tensions. So in that case, we need to use warp knitted fabric. So what you are seeing here is, depending on the purpose for which they are used, we should actually decide whether it is a woven fabric we are going to use, weft knitted fabric we are going to use, or a warp knitted fabric we are going to use. Not only that, we can decide which yarn we are going to use. We can decide even the loop size that we are going to use. And then again, later you will see that because there's many other structures, you can even decide which type of structure you are going to use. All these needs to be decided for the purpose for which, depending on the purpose for which we are using those fabrics. Okay? So when you actually work in the industry, you need to have that information. So these lectures actually give the basic information. Now the area is very big, but during these 3 days of lectures, I need to try to give you as much information as possible. Okay? All right, what else does it say? Weft knitted structures are used for 3D seamless complex structures. Remember I told you about whole garments? When I say whole garments, there are seamless whole garments. There are pullovers that there are machines, we call them whole garment knitting machines. Those whole garment knitting machines can knit the complete knitted garment, maybe a pullover, maybe cardigan or whatever, right? Complete garment in one operation without any seams, either side seams or arm sleeve seams or any seams around here, right? So the machine will knit the garment with different colored yarns, having the garment will have different colored yarns, will have different color patterns, different structural patterns, right? With all of them, the garment will be built, can be built, and the machines can even actually create the, say, buttonholes, pockets, collars, the cuffs, all of them can be knitted in one operation. So we supply the yarn, we supply the design to the knitting machine. Design is actually, it's a computer program saved on a disk. When we actually input that information and run the machine will produce the garment and it falls to the tray at the bottom of the machine. This technology has been there for a long time now, right? So that type of technology, they are actually improving this technology more and more. The capabilities are being increased, right? So weft knitted structures are used for 3D seamless complex structures. When I said seamless whole garments, a seamless whole garment is a 3D shell-shaped knitted garment. Because a garment is like a shell, right? It's a surface all around. So a knitted seamless garment is a 3D seamless shell-shaped garment. Didn't understand that? Okay, right. Let me write it down. right? It's a shell, right? So those whole garments they are 3D garments. They are like a shell. But you might think that's all that it can. They can do solid fabrics as well. They can create 3D thick fabrics. If anybody has heard about spacer fabrics, there are something called spacer fabrics. They are much more advanced technical fabrics. They can be created as well. So wave knitted structures, the machine technology that is available for wave knitting, they allow us to create 3D seamless complex structures. Warp knitting technology hasn't advanced that much, but wave knitting machine technology has gone through much more higher advancement, right? So some of these examples for some of them are medical textiles, smart textiles like garments integrated with sensors and say heating elements, things like that. Different sensors like heart rate sensing, breathing rate sensing, temperature sensing, and many other medical sensors can be knitted into the garment. And then heating. So any say pullovers or something with heating elements built into them, right? Those things are smart textiles. Then those fabrics are smart textiles. Using those fabrics, you can create smart garments. Okay? And then performance sportswear. They are actually, those sportswear are made for certain sports to perform in a certain way. Also, textile composites. Textiles-based composites are there as well. Right? In all these instances, we can use warp knitted fabrics, wave knitted fabrics, and composites are made with woven fabrics as well. Normally, it is made with woven fabrics. However, it is possible to use wave knitted fabrics and warp knitted fabrics to create textile composites as well. Any questions? Yeah.
So most of those garments, do they cost more than?
Yeah. Seamless garments are much more expensive. All right? Okay. So these are some other examples. They are warp knitted structures. Say it's a mesh structure created to prevent birds from picking the fruit of, say, trees. That's the medical garment. So this is an artificial leg. In order to prevent the leg from actually rubbing against the artificial leg, they have that knitted fabric designed. Or this is a compression garment for things like leg ulceration, varicose veins, things like that. And also compression garments are worn for DVT, deep vein thrombosis, things like that. Right? So these garments are knitted. They are useful because the fabric can stretch. And if you knit them with stronger yarn, with elasticated yarn as well, that means fabric can be stretched and put on the leg, and then it actually contracts on the leg, gives pressure on the leg, supports the muscles, and also it can be designed in such a way that there's a pressure gradient from down here to there, so it supports the blood flow towards the heart. Blood return towards the heart is supported by them. Right? So there are different purposes for which these knitted structures are used. Okay? Sorry? They are this is wave knitted. Both are wave knitted. They are both wave knitted. Usually, wave knitting allows you to actually knit a tubular fabric. So there's no seams in them. Warp knitting, well, recently they have made, say, circular warp knitting machines, but they are warp knitted fabrics are generally flat fabrics. So you need to sew it together. So in a, say, compression fabric, if you sew them together, because now the compression fabric is going to have much tension in them, when you put them on, that seam is going to bite into the skin. So because of that, they prefer to use weft knitted fabrics or weft knitting as the method of manufacturing these garments. Okay? All right. So now these structures, we talked about all these applications. Why are knitted fabrics suitable, more suitable for these applications? It's because of the main features in these knitted fabrics, right? So they are open structures. Well, the structure is made out of loops, right? So if it is made out of loops, it is more open than a woven structure. Woven structures are made with yarn packed together. They are interlaced, but they are packed together. Not much air gap in between. Woven fabric is much more like like this, right? Whereas knitted fabric is something that would drape easily. Because of the loop shapes, it will drape easily. They are much more open. There are holes. You don't see them. To normal eye, you don't see them. But if you compare them under a microscope, you will see. Right? Then excellent stretch properties. Okay, as I told you earlier, a loop structure allows you to unbend the loops easily. So that means stretching is easier. Even without elastic yarn, still it can extend or stretch because of the loop yarn path. All right? Then excellent draping properties, same as I told you earlier. Now, woven fabric is something like this. If you try to drape it over, it will be happy bending in one direction, not so much happy bending in two directions at the same time. But knitted fabrics, because of the looped yarn parts, they will more easily drape over something three-dimensional. Not only that, they can be stretched and made to assume the shape of the object. Right? Because of the loop structure. Right? Because stretching a loop is easier than stretching straight yarn. Any questions? Okay, density is less. Again, density depends on the thickness of the fabric. If you are talking about the area density, probably in weaving area density is higher. Because in knitted fabrics, they have loops. The fabric structure is more open. So the area density would be lesser.
So why the intensity will be used?
Density? No, I mean, it depends on the purpose for which you are using it. Now, if it is important to you that the fabric structure is open, then you would go for an open fabric structure. If it is important for you that the fabric structure is stretchable, then you would go for a knitted fabric structure. But if it is important, the fabric is very difficult to stretch, right? Then you would go for a woven fabric structure. Always is the application. Yeah? Open structure means there's more, okay, basically there's more holes. Holes mean, it's not really holes made. The yarn path actually creates openness in the fabric. It's not that you have somebody pierced holes in them, right? It's more open because the yarn path is a loop path. That's the reason. All right? Okay? Then, ability to engineer thermal and fluid transfer properties. Okay, same as I told you earlier. Now, if, say this is somebody's, okay, body, torso, cross section of the torso, right? Now, in the body, so on the surface of the body, or generally they say the core temperature is about, say, 37 degrees centigrade, right? So we'll say core temperature is 37. So there would be generally higher temperature here, but here this is air, right? The temperature goes down very fast and then settles down at the environmental temperature. Near the body, it is much more warmer. Even a centimeter away from the body, it is much more cooler, right? Now, if you put a fabric, knitted fabric, which is much more open, maybe we can make it to stretch over the body and body hugging garment, right? When it is near the body, it can maintain a warmer layer of air next to the body. So it makes you feel warmer. That means thermal management, right? You can manage the environment next to the skin. Then fluid transfer properties. When a person sweats, that sweat needs to be moved away from the body, right? So if it is an open fabric structure, open means they are less dense, right? If the fabric structure is less dense, then the moisture will be absorbed by the fabric structure. Now, because the fabric structure is open, there's heat radiating away from the body, and that can carry the moisture easily out of the body. Woven structure can't do that easily. You can't wear a woven body hugging garment. Well, making that will be difficult, I think. And if you get into that, even, I don't know, it will be difficult to get into a woven body hugging garment, right? Unless it is made completely of elastic material or something like that. Okay? So knitted fabrics allows you to stretch them and have body hugging garments. And because of the openness in the structure, it allows for moisture like sweat to be moved away from the body much more easily, which is the fluid transfer properties. Okay? All right? Three-dimensional complex structures can be produced without seaming. We discussed this earlier as well, right? The knitting machine, the weft knitting machine technology is so advanced these days. We can actually use them to make thick fabrics, thick shaped fabrics, or seamless fabrics, or complex structures, complex color designs. Any of them can be made, right? There are certain limitations, but the possibilities are much higher, right? That's why this is saying three-dimensional complex structures can be produced without seaming. So you can create seamless. Being seamless is very important in certain medical garments, right? Again, if you wear seamless garments, they look much better, right? Okay. So probably I think, so it's something like this. It's an animation, right? So this is a Shimashiki whole garment knitting machine. You can see how it operates. So the knitting machine is something like this. Okay, incidentally, the large number of students in this class doesn't allow me to hold lab classes, knitting lab classes, right? Because of the other lab classes there as well. However, still, if any of you are interested, you can go to the knitting lab and look at those machines if anybody is interested, right? Of course, you can actually look at these machines, images of these machines in the internet. But if you want to see real machines, you can go to the lab. And if a group of you comes, if I am free, I can even come with you and show them to you as well, depending on the free time. Okay? So what happens there is, the part that is moving, it's called the carriage. Carriage moves back and forth, and while doing that, it knits a garment, a complete garment or whole garment. The garment will be seamless because there's no sewing in the garment, right? When it finishes, it falls into the tray at the bottom of the machine. So from where the knitter takes the garment out, any yarn that yarn be sticking out, which needs to be removed, they will be cleaned away, right? And then packaged and sent, right? So these machines are called, this type of machine is called a flatbed knitting machine. They are electronic flatbed knitting machine, and they are certainly CAD operated. There's a CAD software that is used to create the garment design, and then that design is fed into the machine, and machine is threaded with different yarn, and then it is run, and it produces everything without any intervention. Okay? Okay. So same as I told you earlier. Now, because this area is new to you, you need to know about the terminology used in relation to knitted fabrics, right? You need to be able to say, okay, point to different areas of the fabric, different sides of the fabric, different parts of the loop in the fabric, and continue a conversation with a knitter or somebody else regarding the properties of the fabric, right? So in learning about this, the first step, in order to create a knitted fabric, say we are looking at weft knitted fabrics, okay? First we have two sets of loops. We interconnect them, right? And then again we interconnect another set of loops, horizontal or weft direction set of loops, right? This is not the exact way by which the fabric is manufactured, but this is an easy way of understanding it, okay? So now if you connect 3 of those sets of loops, you end up with something like this. If you connect more than that, maybe 100 or so, right? You would always then have the top set of loops, the bottom set of loops, and many other loops in the middle of the fabric, right? That's what you would have. So we need terminology to name something to call the first set of loops, something to call the bottom set of loops. Now all the others look alike, right? All the others would have this type of contact points along the yarn path. So the top set of loops is called knitted loops. So the knitted loops have 2 binding areas only, at the 2 binding areas at the bottom of the loop, okay? This set of loops is called yarn loops. They have 2 binding areas at the top of the loop. Is it clear? Right? So if this is the loop, at the top of the loop there's 2 binding areas. So that's knitted loops, this is yarn loops. And the loops that have 4 binding areas, they are called stitches, knitted stitches. So we need to know about this terminology in order to conduct a conversation, right? Do you need to, yeah?
If we add another set of the loops,
Yeah, if you add another one here, then this one will become knitted stitches. The very top one will become the knitted loops. Okay?
So everything in between the knitted loop and the yarn loop
Are knitted stitches. Yeah. Yeah. Okay. Do you need a break? Okay. 5 minutes? See, I don't have much time to teach, so only 3 days. So can you come back in 5 minutes? All right? Okay. In 5 minutes we'll start, okay?
I want to change my calendar's time because the time is the same time with my other course.
It is clashing.
Seminar time.
Seminar time is clashing with another lecture.
This lecture seminar
Next week, yeah. Okay, can you send me an email? All right. So you mean that you have another lecture at the same time? Okay. Send me your name, ID number, right, and your current seminar time, right? That's a warp knitted structure. Yeah.
What means the stronger yarn and the
Yeah, they are strong yarn and they are mesh structures. This type of mesh structures, it is warp knitting that produces them.
And then all knitted structures can have seamless structure.
No, not all. See, the pullover you are wearing, right? It has a sewing line on the side. Can you see? On the side. That means it has a seam. It has a seam, right? Seamless garments, they don't have a seam on the side. It's the way it is manufactured. It's a, no. They can produce seamless structures. Not all of them are seamless. They can produce seamless structures. Okay? Not all of them. Yeah. All right. At 2:40, that lady who was here earlier, she's going to come back. She's going to come back. Tell her when she comes. Which one? Formal outerwear, like a suit. Yeah. No problem. Okay.
Before it is widely manufactured nowadays.
Oh yeah. Oh definitely. Yeah. Whole garment knitting. This is very much used. Go to the internet and search for whole garment knitting, shimashiki knitting machines. Then you will find those machines.
It's not like made from clothes, whole clothes. They are cutting.
These are actually sewn. So you have a seam here, you have a seam on the arm here. They are cut and sewn. They can produce shaped panels, or they can produce flat fabrics, or they can produce seamless garments. Any one of them.
Backward and forward together.
Yeah.
The material can be used like wool or
Oh yeah, definitely. Oh definitely. There's many different yarn types that can be knitted.
and this is also we have at house school in the secondary school.
Oh yeah, in the Sackville Street building. Yeah, if you are interested, Sackville Street, go to the knitting lab. There's a technical officer there. Her name is Laura. Talk with her and ask her to show you around.
Which factor decides the level of structure?
Okay, it is quality of yarn and the structure, both of them. If you use an elastic yarn and create a loop structure, it will stretch more. If you use a very stiff yarn and create a knitted structure, it will only unbend. Yeah.
why the latter is much more stronger?
That's because the type of yarn used are strong yarn. Now for weft knitting, the yarn doesn't actually get tension so much. So they use weaker yarn in order to save money. Okay, in order to save money, they use weaker yarn. But for warp knitting, you have to use strong yarn. So because of that, warp knitted structures are much more stronger.
Is there a relation between stronger and something more
Strong, the strength actually comes mainly from the type of yarn that is used, yarn material. If the yarn material is strong, then the structure is strong. However, you can actually adjust the structure as well in a certain way to increase its strength so that it doesn't stretch so much. Both of them can be engineered.
When we talked about the application of web knitting structure, shows that it can be used to sportswear.
Oh yeah.
And when we talk about the application of warp knitting, you also mentioned
Yeah, for both of them you can, yeah. Say like a swimwear, like swimsuit. You can actually create the swimsuit using weft knitted fabrics or warp knitted fabrics. In weft knitting, you can create it seamless. In warp knitting, you will be creating it with seams, cut and sew. Say warp knitted fabrics, when you use warp knitted fabrics to create a swimsuit, there would be seams. Understand? Okay, sportswear would be an overall general term. Performance means to perform a certain way. There are certain key words being used. You can actually find, people made them up. You know those keywords, people made them up. Like saying smart fabrics. Right? Nowadays they are calling everything smart fabrics. Right? Like that, people made those words. So performance there means those fabrics are actually created to perform in a certain way. Generally, warp knitted fabrics are more stronger than weft knitted fabrics. Okay, no problem. Hi.
first 15 years twice the
Interloop because in knitting you only need one end of yarn. You create loops, and then again the same yarn is used to create another set of loops through the previous one. Yeah, same yarn keeps on going back and forth. Yeah, so you only need one package of yarn. Warp knitted is strong yarn. Yeah, okay.
It means that the yarn was knitted by this dating is strong.
It's like this. For warp knitting, the type of yarn they use is much strong yarn.
So it means that we use the strong type of yarn to
Yeah. And also, not only the yarn, the structure is made in a certain way that it adds strength as well.
So it also that the structure is stronger.
Yeah, structure is strong as well.
And the third it means that only web knitted, only web knitted high low wearing.
If it is only weft knitted, right? Depending on the type of yarn you use, depending on the structure you used, you can change its performance. But when you compare it with the warp knitted fabrics, weft knitted is slightly weaker.
So it's just
If you compare it like that.
this kind of knit is high load and this kind of knit.
Warp knitting is high load bearing.
Yeah.
Weft knitting is not so high load bearing.
So it's also the seamless.
With weft knitting, you can create seamless garments. Yeah.
And it combines them with
What is? Oh no, you don't combine them to make textile composites. You can make textile composite using either this type of fabric or this type of fabric. Yeah. Okay. All right. Okay. So if we go to the next slide, we have about another 20 minutes. Okay, settle down. All right, we are starting on this slide now. So we looked at the arrangement of sets of loops, and we learned about the terminology that we use to talk about them, define them, right? The next part is about the loop. So in a knitted structure, the basic building block of a knitted structure is the knitted loop. What you see there. What I mean is this yarn, the white yarn, okay? The middle of here to middle here, along the yarn path, that is the knitted loop. But because it is inside a knitted structure, you can see that there's other yarn binding them, right? So it's this white yarn from here to here is the knitted loop. So in the knitted loop or knitted stitch, you can see that upper area there's two binding areas, lower area there's two binding areas. Okay? Now if you look at knitted fabric, a basic knitted fabric, you can see that continuous yarn, the continuity of the yarn loops is in the horizontal or weft direction. So I kept on saying set of loops, right? In here, for weft knitted fabrics, the horizontal set of loops is called a course. That's the term that we use. It's called a knitted course, right? And vertical set of loops, there's no continuity in them. This is just imaginary, so we just colored it yellow so that you will see as arrangement, right? So the vertical arrangement of the loops, that is called a veil. It's a knitted veil, right? So generally, the angle relationship between them is each one is perpendicular to the other. But in knitting, this can be changed. While maintaining the knitted course horizontal, generally you have the veil perpendicular to that. But depending on the way you knit, you can make it at an angle as well. Right? However, in order to understand this, just take that the horizontal set of loops is the course. Horizontal set of loops in the weft direction or weft direction set of loops is called the course or knitted course. And the vertical arrangement of the loops is called the knitted veil. Okay? Then we come to the main building block of the knitted structure, that is the knitted loop. Now the knitted loop starts from here, ends here, right? The top part is called head. The longer parts are called the legs of the knitted loop, and these are called the feet of the knitted loops. Right? Those are the terms that we use. Okay? So in this structure, head of the loops, legs of the loop. So you can see in this knitted structure, you can see the legs of the loop because the fabric structure is drawn in such a way that it is like it is stretched, right? It's stretched. Because it is stretched, you can see the legs of the stitches. If it is not stretched, this will collapse and become very dense. From this side, you will only see the heads of the stitches and the feet of these stitches, right? From the other side, if you go to the other side, then you will only see the legs of the stitches. If you can imagine about this picture in a three-dimensional way, looking from this side, if this fabric is actually dense, very dense, then you will only see the heads of the stitches and the feet of the stitches. Legs would be hidden inside the structure. But if you go to the other side and look at the structure, then you will not see the heads and the feet of the stitches, but only the legs of the stitches. It's the same if you look at the knitted fabrics, say the pullovers you are wearing. If you take a magnifying glass and look at them, you will see in one side you only see the legs of the stitches. Now if you turn it the other way and if you look through a magnifying glass, you will see that you can see the heads and feet of the stitches. Okay? That's the same thing that this is trying to show. Normally, all the sketches we have, they are drawn stretched so that you can see the yarn path clearly. All right? Any questions? Okay. Right. All right. So we also talked about, okay, any fabric, they have two sides, right? So the structural pattern you see from one side may be different from the other side, right? For basic fabrics, the front of the fabric, front side of the fabric is defined as the side from which you can see the legs of the stitches. For basic fabric structures, for basic knitted fabric structures, the front side of the fabric is the side from which you can see the legs of the knitted stitches. The reverse side is called reverse. So other side is called the reverse side. So the stitches you see from there, reverse stitches or back stitches, they are the same stitches. We are, depending on the direction from which we are looking at it, we call this. You can't actually, it is sometimes it becomes difficult to define what side is front, what side is reverse side. When the fabric structure becomes very complex, it is difficult to say, difficult to use the same rule. But for basic fabric structures that you are going to use or we are going to learn about during these lectures, right, you can use this rule. Front side is the side where you can see the legs of the stitches. Okay? So the front side, also called technical front. Reverse side is called technical back. Okay? Okay. So we learnt about the basic terminology that is used in, say, talking about fabrics. Right? We learnt about how to call different parts of the knitted loop. We learnt about the front side of the fabric, reverse side of the fabric. We learned the terms for a set of loops in the weft direction, that is course, knitted course. We learned about arrangement of loops in the warp direction. They are called a knitted veil. Right? Also, we learned about what is the top set of loops, what is the bottom set of loops, anything in between, what they are called. We learned the terminology such as binding areas. Right? So these are the terms that you use to talk about a normal basic knitted structure. Now, as I told you earlier, loops can be interconnected in so many different ways to create very large number of different knitted structures. However, we don't have time to go through all of them and learn about the properties of all of them, right? So because of that, in order to make it easier for you, we have something called basic knitted fabrics defined. So generally, the idea is that these basic knitted fabrics are the most basic. So even to manufacture, they are the most basic structures, which when combined in different ways can produce more complex fabric structures. Right? So the basic knitted fabric structures, they are the plain knitted structure, rib knitted structure, pearl knitted structure, and the interlock knitted structure. It's in the order of complexity. Plain knitted structure is the most simple structure. All the structures you have seen up to now, they are plain knitted structures. Okay? And then rib knitted structure. These structures are available in your the garments that you are wearing. Say, okay, I don't have, but say anybody who's wearing knitted, say, pullovers. If you look at the cuff, right, the structure in the cuff generally, in most cases, is a rib knitted structure. We'll learn about what type of structure is that later. Then plain knitted structures, you could have them on the main part of the either back panel or the front panels of a say pullover, right? Could have plain knitted structures, or the sleeve, or in a single color pullover you could have them. Now the pearl knitted structure is again it is similar to a plain knitted structure, but its construction process is much more complex. Each course of pearl knitted structure takes generally about 4 knitting steps to make. Right? In a pearl knitted structure, what you have is both sides you have a reverse stitch weave. In plain knitted structure, in one side you have the front weave, in the other side you have the reverse weave. Rib knitted structure is very stretchable. Anybody who's wearing, say, knitted, what do you call them, hats, right? They are rib knitted structures. They stretch. They can stretch. You can stretch them, put on the head, then they contract and hold on to the circumference of the head. Right? Then interlock knitted structure, that's the strongest fabric structure. Interlock knitted structures, they're difficult to stretch. They're quite difficult to stretch. Okay? Any questions up to this point?
Interlock knitted structure, you say strongest knitted structure, right?
Well, out of these four, it's the strongest. Yeah. It's because when I say strongest, what it means is that difficult to stretch. Okay? All right? Any other questions? Okay, we'll go to the next slide. All right, so next what we are doing is, we are looking at each of the 4 basic knitted structures and looking at their properties, characteristics or properties. Okay? So, some of the information here, they relate to the way in which the structure is manufactured. Generally, say you could have, say generally, now in order to create flatbed knitted structures, in order to create weft knitted structures, mainly there are 2 types of machines you can use. One is called, oops, right. One is called flatbed knitting machine. The other one is called circular knitting machine. Okay. Now, flatbed knitting machines, they are the ones that you saw the animation. The animation is there you saw a flatbed knitting machine. It's the technology of the flatbed knitting machines that have advanced much further than the other machines. The technology in flatbed knitting machines are much further ahead than circular knitting machines, warp knitting machines, say complexity-wise, even weaving type of machines as well. I mean, the things that they can do. They can create different, say, seamless garments, seamless products, solid products. The different, say, for product development, they are very good. Right? Circular knitting machines produces a tubular fabric. Now, this technology has advanced to a certain level. Some of you may have heard about, there's a machine manufacturer called Santoni circular knitting machines. They can produce actually nearly seamless garments. YouTube has many videos of them, right? In your handbook, I think probably there's a web link there as well. There's a web link called Knitting Industry. I think it is knittingindustry.com, right? If you go there, that's the best place to find out information about knitting machinery, various knitting machinery, right? So, out of them, our discussion will be mainly based on flatbed knitting machines, okay? Because if I keep on talking about all the different types of knitting machines, it will become difficult for you to understand. So from this point onwards, I will actually, whenever I talk about knitting machines, unless I specifically say, I will be talking about fabric structures produced using flatbed knitting machines. Okay? A flatbed knitting machine is something like what you saw in that animation. Alright? Okay. So, plain knitted structure, all stitches are formed by interlooping yarn in the same direction. Okay. What it means is that those flatbed knitting machines, the most basic machines, they have two needle beds, two sets of needles. Is it difficult to understand? Because, right. I am supposed to talk about knitted fabric structures without talking about the knitting machines, because there's no time to teach you about knitting machines, right? All right. In that case, you need to actually take this as true, right? What this means is actually, when you create the plain knitted fabric, right, you only use one needle bed. Generally, there are two needle beds. But in order to create the plain knitted fabric structure, you only need one needle bed. If you come to the knitting lab, I can show this to you. Right? The other thing I can do is, at the next class, I can actually show you some images of knitting machines, and there point out what are the knitting needle beds are like. But generally think that this is because you don't need to write about them, right? Generally think when it says interlooping yarn in the same direction, what it means is that it's only using a single needle bed. Okay? I think right about now, Olivia from the administration office will be coming, right? Oh, right. You can come. Yeah. So we'll continue this. We'll have to stop at this point. We'll continue this from next week. Okay? All right. Thank you for listening.
I like to hear that.